as in thumbnail, I will tell you about how energy derived in physics. We recall that Newton's laws of motion, which summarize to force factor equals to first derivative of momentum factor equals to m multiplied by second derivative of position, which is in this condition I choose to first derivative m is equals to 0 or conserved mass in closed system. So that's the characteristics of system we know in real life. And then we have a question. Is force enough to characterize our system? By these questions, we have a problem that non-zero force factor is not guarantee that V factor is non-zero. So to give you some illustration, let we call again M, and then I kick it, which it bring F force factor for M, and the questions now is M may not moving? Unfortunately, in real life, it may be yes. Woo! I'm right! Woohoo! By that problem, we define that W capital or known as we walk the talk is equals to integral with lower bound is S initial and upper bound is S final, which S told you about state. But for now, we told you that state is defining a position. So that means this integral told you about interval of displacement of position, which is displacement of state, which the inside of integral is f factor dot product with ds, which is ds factor is little slice displacement, just like partition in Riemann sum, and F factor is total force of system, which told you total force of system. So that means W capital tell you how force displace or shifting our system by some state parameter. In this, it means position. So by definition of force, we will get this. And by this, I replace R factor with S, which is it has a same definition for displacement, but for exact position, it's different. So then we have this result. In other form of definition, we will get the integral just like this, and by substitution again, we will get this too, and using product rule for f multiplied by f is equals to like this, which means now we will have result as integral but interval in time with integrand as the first derivative of 1/2 m multiplied by v dot v with respect to time. Integrate with respect to time. Inside this differentiation, we will have kinetic energy definition because of this factor inside, and I denote this as T, which is this integral by fundamental theorem of calculus. We will have result as Tf subtract by Ti, which is this known as work energy theorem. So that the final result remain like this. And by equating both before and after result, we will have this equation, which is P as power known have relation with F factor, and of course by this result too it will have relation to T. So then we defining P is equals to minus first derivative of V capital, which V capital told you about energy that stored or saved, which is not used as T yet. So I put minus sign here because if we have more T, then we will have less V capital. And if we have more V capital, we have less T, and so on. So that V capital is described totally everything in our system. doing substitution to P like this, and by moving right hand side to left hand side, we will have this equation which result as 0 in right hand side. Inside this differentiation, I denote this as H capital, known as total energy. It means that the result of this integral is H capital F subtract by H capital I is equals to 0 if and only if H capital F is equals to H capital I, which known as total energy conservation. And fun fact, I choose H capital here to tell you that this is a Hamiltonian function for Hamiltonian mechanics later. Finally, we have H capital is equals to before, and this has characteristic as first derivative of H capital is equals to 0, and as I defined before that, first derivative of M is equals to 0 too. In H capital, V capital equals to all energy is saved for raising T, which is T is equals to just before as kinetic energy, and this result lead us to first law of thermodynamics. And not to be confused, H in thermodynamics later is enthalpy, but for this session or this video about classical mechanics, I define H capital as a total energy. So that's how energy told you about everything in physics. Started with a simple definition and then you get interesting result to describing the universe using physics law. I think that's it. Thank you for watching. Don't forget to like, share and subscribe, and see you later.